Okay, geometry, I am home with a sick kiddo today, but we are going to continue on section 2 notes on Friday, I think, yes, Friday, no, like Wednesday was the last day we were together, and we talked about conditional statements like conjunctions and disjunctions, where you're looking at two statements together and trying to figure out whether they are true or false, depending on whether they're and or. And then the last thing that we ended up doing was writing a statement in if-then form. So an if-then form had a hypothesis and a conclusion. And so taking like a mammal is a warm-blooded animal and putting it into if-then form. Okay, keep in mind that when you do that, you're not allowed to add any additional information in. So not allowed to say anything about them having 4 legs or how they carry their young, or like they don't lay eggs or any, whatever. You're not allowed to say anything like that. It's just if something, then something, using the information that's given. Okay, now you're going to get a little ticked off with this next box right here. Okay, and please don't shoot the messenger. I'm really glad I'm gone for this section, because you're going to yell and throw things and it's not going to make a whole lot of sense. And I know Luke is going to have a fit with this. Okay, and possibly Kyle. All right, so don't kill me. All right. This section talks about the truth value of a conditional statement. Okay, so we have a conditional statement. We have if something, then something. So we're talking about if Tom finishes his homework, then he will clean his room. Okay, and we're talking about the truth value of that. All right, if Tom finishes his homework, that's the hypothesis, and then he will clean his room is the conclusion. Okay, so he's talking about finishing homework first and then cleaning his room second. Okay, that's kind of important here. Okay, finishing his homework, then cleaning his room. All right, now, if he finishes his homework and he also cleans his room, and those are both true statements, then the whole thing is true, right? He finishes his homework, he cleans his room, everything's true, right? Okay, but if he finishes his homework, which is true, but he doesn't clean his room, then he failed to do the entire thing, right? Okay, so if Tom does not clean his room after he does finish his homework, then he has not fulfilled his promise and the conditional statement is false. This is where you're going to get ticked off. Okay, are you ready? So if the first statement is false, like if he doesn't finish his homework to start with, then we don't care what he's doing next, because he didn't finish what he was supposed to do to start with, right? Like, great that he cleaned his room, but you didn't finish your homework first, so, whatever. So if the first statement is false, okay, it says the conditional only indicates what will happen if he does finish his homework. We don't know anything about if he doesn't finish his homework, what will happen. We only know that if he finishes his homework, then he will clean his room. Okay, now this is where you get ticked off. If the first statement is false, regardless of what these next two statements are, the whole statement is true. And it's frustrating to me, and I totally get it, but whatever. If the original statement is false, then the whole thing is true. If Tom finishes his homework and that is false and he doesn't get it done, then the whole statement is true. Okay, so like on your homework assignment, you'll have things that are like, if there are purple monkeys on the ceiling, then the moon is blue. I don't know. Well, false, there are not purple monkeys on the ceiling, but the whole statement is true because the first statement is false. Okay, it's frustrating. I get it. There is some sort of logic somewhere to it, but that's how that works. If the first statement is false, the whole thing is automatically true. Okay, so here's the deal. Let's go down to these and let's identify the truth value of these guys, all right? So if you divide an integer by another integer, then the result is also an integer, okay? So this is the hypothesis, and this is the conclusion, okay? So we're going to talk about the truth value of these individually, okay? So if you divide an integer by another integer, you're allowed to do that. That is true. We can do that. But the result is also another integer, okay? So let's think about this. If we divide an integer by another integer, like let's say we divide 6 divided by 2, right? That's another integer, which is 3. Okay, but what happens if we divide like the integer 2 by the integer 3, right? 2/3 is a decimal, which is like 0.6 repeating, and that is not another integer. Okay, so this statement is false because I have just given you a counter example, which is this guy right here, counter example. Okay. So I guess in the instructions, it says determine the truth value of each conditional statement. If it's true, explain your reasoning. If it's false, give a counter example. So I just did that there. Okay. So the result is not always an integer. It could be an integer like in this case, but it doesn't always have to be like the counter example that I gave. Okay. If the next month is August, now the next month is not August, which kind of makes it a false statement to begin with. Next month is not August. False, right? So that automatically kind of makes the whole statement true. But let's say that just looking at this thing, that next month is August. Let's just say that next month is August. That's true. Is this month going to be July? Yes, true. So the whole thing is true. Okay, so that one's kind of weird. Next month is August, this month is July. If you just look at it as a whole and don't try to break it down using the fancy math that we've done, obviously that comes out to be a true statement. Next month is August, this month is July, makes sense. Okay, now part C, don't throw things at me through the computer screen. If a triangle has 4 sides, a triangle does not have 4 sides. But if it did, then it is concave. Okay, that is true. If a triangle has 4 sides, it's false. Okay, in an alternate universe where a triangle has 4 sides, it might as well be concave because it has 4 sides and it can be whatever it wants to be if a triangle has 4 sides. That is a true statement according to this little bubble up here. Okay, I don't agree with it. I don't like it. You know, that's just the way that it goes. But anywho, that's the math that we live in. All right, if a triangle has 4 sides, then it might as well be concave in an alternate universe where that exists. Okay. Don't throw things at me. Don't yell at me. Okay. All right. That's the end of that. All right. Now we get into things that are a little bit better. Okay. You know, still kind of, you might not like it because it's kind of an English lesson now, but we have something called a conditional statement, which is what we've been doing already. These are the if-thens. If, then. Okay. And they write that as PQ. So P is the if part, Q is the then part. Okay, this is called a conditional statement. Okay, now you have something called a converse, an inverse, a contrapositive, and all that good stuff. Okay, the converse is the reverse. I like to say it. Converse is the reverse, and the reverse is taking, instead of doing PQ, it's Q then P. So you're just taking that and flipping it around. We'll do that to this statement down below here, okay? Converse is the reverse, okay? The inverse is the not original, okay? Not original. So it's taking the original and making it a not, all right? The inverse, the original went PQ. This one is going not P, not Q. These are the little squiggly marks, squigglies if you can't see them very well. So it's just taking the same order as they were in. It's just taking the same order as the original guy, but it's just nodding it or inverting it, okay? Making it negative, okay? It's negating the original one, okay? And then the contrapositive negates the converse, okay? So the converse went QP. This is still going QP, but it's not Q, not P, okay? So it's taking every single possible combination of those two statements and doing stuff to them, right? PQ, I could flip it around QP, or I could make each one of them not. I could flip them around and make each one of them not. It's taking every single possible combination of that statement and doing that to it. Okay, so contrapositive is the not converse. Okay. All right, so let me write these down here. Lions or cats that can roar. The conditional statement goes PQ. Okay, the converse goes QP. Okay, then these two go together, the conditional and the inverse. This is PQ, except it's not in front of each one. So not Q, not P. The contrapositive goes with this guy, so this is not Q, not P. Okay, so that's kind of the way that these go. Okay, all right, so let's write out lions or cats that can roar in if-then form. We need an if-then for lions or cats that can roar. So I'm going to say if it is a lion, then it is a cat that can roar. Okay, true or false? If it is a lion, then that means it's a cat that can roar. Now, Kyle and Luke and maybe Chase, if he's in this boat too, okay, we're not talking about like defective lions whose voice boxes are not working, whatever. Okay, we're talking about a regular old normal lion If it's a regular old normal lion, then that means it's a cat that can roar, and that is true. Okay, if it is a lion, that means we have a cat that can roar. True. Okay, the converse is flipping those two around. So if, I'm going to paraphrase, if cat that roars, then lion. Okay, so if it is a cat that can roar, does that mean it has to be a lion? If it is a cat that can roar, then it has to be a lion. Like what I have in my possession right here is a cat that can roar. Does that mean I am possessing a lion right now? Not so much true, right? This could be a tiger instead. So I'm going to say a counter example. Counter example. Counter example. Could be a tiger or any other cat that can roar that's not a lion, right? That's false. If it is a cat that can roar, that doesn't necessarily mean it's always a lion. So that's false, okay? Now, it won't always be the case that these two will be opposites from each other. They both might be true, right? Okay, but if one is true, that doesn't always mean that the other one is false. Okay, so don't think that that's the thing. Okay, the inverse. So we're taking this original statement, but we're putting not in front of it. So if it is not a lion, then it is not a cat that roars. Okay, so I have an animal here and I know that it is not a lion. Does that mean that this animal right here cannot be a cat that can roar? False. I could have a tiger again, right? False. Counter example. It could be a tiger, right? Let me say that again. If what I have caged up next to me is not a lion, it still could be a cat that roars. It still could be a tiger. Right? So false again, all right? The contrapositive is taking this statement, Q then P, so it's taking this guy right here and then putting not in front of it. So if not a cat that roars, then it can't be a lion. Then not lion. Okay, we're literally taking every single form of these two statements together and jamming them together and trying to figure out whether it's true or false. Okay, so I have something caged up and I know it's not a cat that can roar. Okay, what I have caged up is not a cat that roars. So does that mean that what animal I have in here can definitely not be a lion? It's not a cat that can roar. It definitely cannot be a lion. True. Okay. All right, so you have to kind of think about those a little bit and how you flip around, how that makes the statement negative or positive, whatever, okay? So that's kind of how that works. All right, now, something called a biconditional statement is like putting the conditional and the converse together. So it's doing P then Q and Q then P all in the same statement. That is called a biconditional. Bi because it means two, right? Bi means two. All right, so here's my example. They've done this one for me. Okay, the example says if statement P is angle O has a measure between 90 and 180. Okay, so angle O is some obtuse angle, whatever, right? Angle O is an obtuse angle. So angle O has a measure between 90 and 180. Angle O is an obtuse angle. So what they've done is they're saying angle O has a measure between 90 and 180 if and only if angle O is an obtuse angle. And what that does is that does the regular and the regular conditional and the converse all at the same shot. Okay, this says angle O has a measure between 90 and 180. I'll say if angle O has a measure between 90 and 180, then angle O is an obtuse angle. And it also says if angle O is an obtuse angle, then it has a measure between 90 and 180. It's doing both of those things at the same time, and it's using the words if and only if to separate them. So when you see these words, it's just meaning doing those two statements at the same time without having to write it twice, right? It's saying if this one, then this one, and it's saying if this one, then this one. It's doing both of those at the same time, jamming in together, using the words if and only if in the same thing. Now, when I took logic sets and methods of proofs in college, we used IFF to be the statement if and only if. That is a generally widely used abbreviation of the word if and only if. So if you want to do IFF, instead of writing out the word if and only if, you sure can do that. That is like the generally accepted abbreviation for if and only if, okay? So let's do this one. Rewrite each statement as biconditional, then determine whether the biconditional is true or false. Okay, so A says a number of the form 2k plus 1, where k is some integer, then the number is an odd number. Okay, and if, so let's see, we want to put it in the if and only if form. Okay, so a number is of the form, I'm going to do this, is of the form 2k plus 1, where blah, 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 blah. If and only if the number is odd. Okay, a number is of the form 2k plus 1, where k is some integer, if and only if the number is odd. Okay, so let's look at both sides of that. Okay, if a number is of the form 2k plus 1, okay, then that number is an odd number. So like 2k plus 1, and k is a number. I'm plugging any number in there, like 7. 2 times 7 plus 1, is that going to be odd? Yep. Let's say this number is 10. 2 times 10 plus 1. Is that number odd? Yep. So no matter what I plug in for k, it's always going to be an odd number. Great. Okay, now let's go backwards the other way. If it's an odd number, if it is an odd number, can it always be written in the form of 2k plus 1? Let's try it this way. Let's take the odd number, I don't know, 13. 13 can be written as 2 times 6 plus 1. Great. Let's try the number 31. 31 is 2 times 15 plus 1, okay? Any odd number can be written in the form of 2k plus 1. So this whole thing is true because we've looked at both sides of it, okay? All right, last one, part B. We want to write this in if and only if form, okay? So lines that do not intersect are parallel. So we will say lines do not intersect if and only if they are parallel. Okay, let's start with the backward ones. Let's start this way. Okay, if lines are parallel, then they do not intersect. True? Yes. If lines are parallel, then they do not intersect. That part's true. Okay, now let's go backward the other direction and let's say if lines do not intersect, then they are parallel. If lines don't intersect, then they are parallel. And you're probably thinking, yeah, they have to be parallel, right? Unless we are in three-dimensional space, right? Where we have like two lines that are skew. I can't even draw skew lines because you have to be thinking in three-dimensional space. So think about like two lines that are like not parallel to each other, where one like line is like over top of the other one. I'm trying to do the motion with my hands, but you can't see my hands. So stick one arm out in front of you and put the other one over top of the over top of your arm, and that's what skew lines would look like. Okay, so they're not intersecting at all, but they're not parallel either. So that statement is false, because in one direction, yeah, if they're parallel, they don't intersect. But if they don't intersect, that doesn't necessarily mean that they're parallel. Ugh. This is like an English lesson. It's crazy. But it helps you start to think about like, okay, really like the specifics of things. Like, you know, this is going to help us later on when we start to try to prove things, okay? It's really trying to get you to be detail oriented and pick up on the really, really, really minute, like close, you know, like, is it really though? You know, that type of questioning, okay? All right, so on your homework assignment, you have the rest of the, I think we did 1 through 5 on both sides for today, but if you don't have it done, make sure you get to working on that, and then the bottom half, do that for the rest of the time, okay?